Hi everyone. This bite-sized video we're going to be looking at writing expressions. So before we get into that, we're going to look at some of the basic rules. The first one is expressions regularly swap out words for letters. If it helps, write out a sentence with just the words first, and then we can substitute the letters in later, and that can help us get to our final expression. That'll make a little bit more sense when I look at some of the questions for you. But some people prefer to write out in words first and then substitute in the algebra. So if that method works for you, then by all means use it. The second rule with these is going to be expressions can be a simple mix of numbers. So it can be something just as simple as 2x. It can be something as simple as 2y. But there can also be sort of a mixed expression, if you like, such as 2x plus 2y plus 4. So often what a lot of people do is they'll find the expression for something and they'll think it looks too simple because it's just got a 2x or a 2y. Don't be afraid of that. It doesn't always have to be a complicated expression. Quite often it can be something fairly straightforward. So don't be kind of trying to make it more complicated than it has to be. Next one is expressions will not require an equals sign. So if it's got an equal sign in it, the odds are that it's an equation. It's not expressions. We're not kind of giving an expression for something. So if the question's got expression in it, the odds are that you will not be using an equal sign during that. So don't fall into that trap of feeling as though you have to put an equal sign in it just because it's maths. Algebra, you don't have to. And the last one there is expressions can be used to help you work out wordy problems too. So often on an algebra paper, you'll be given a question that doesn't seem to have any algebra in it, so there won't be any terms given in there, so you won't kind of have any x's or y's in the question anywhere, and it stands out a little bit on an algebra paper. You might just think that you're getting lucky that you don't need to do algebra for that question, but more often than not, what it's trying to get from you is for you to use an expression to get the answer. There's a couple of those questions below, and I'll cover those when we get to them. But it's just something to bear in mind that if you see a question without sort of any algebra in it on an algebra paper, you should be wondering why. So bearing those rules in mind, we're just going to have a little wander through a few of these questions for you. So this first one here is pencils cost X pence each. So we don't know the value, so we don't know how much they cost, so we're just giving it an X for now. And all it's asking is to write an expression for the cost of 5 pencils. So if a pencil costs X pence, 5 pencils must cost 5 times as much. Now there's a couple of ways you can do that. If you're quite happy, you might have already figured this out. You simply just do 5 times X, which is 5X. Now you can jump straight to that point if you want to, and there's absolutely nothing wrong with doing that. What some of you may like to do is kind of a more step-by-step approach, where you might say you have X there, and we're just looking to go to 5X after. And you might want to have a little think about how we get there. It's not really necessary for a question this simple, this straightforward. But if you want to get into the habit of doing it for more complicated questions, you can. So our next question here, rulers cost M pence each, and rubbers cost N pence each. So write an expression for the total cost of a ruler and a rubber. So as I was saying in the rules above, sometimes it helps just kind of figuring that out in sentence form first. You don't have to, but basically if we were going to work out the cost of a ruler and a rubber, we would have the price of a ruler plus the price of a rubber. And in the question there, it's letting us know that rulers cost M pence, so rulers, we can substitute the letter M there instead of putting ruler. And we just add on whatever letter it gives us for rubbers, which is N. And that would give us our total cost. m plus n. So your answer here can just be as simple as m plus n pence. Which makes sense if you think about it. So let's say a ruler was 10 pence and a rubber was 10 pence. You know, if we put in 10 plus 10, we'd get 20 pence. Same as with our m and n here, we could put 10 and 10. It'd still give us 20. So it's just giving us a total cost. It's just another way of writing it down. Now this next question is one of those ones I was telling you to keep an eye out for, which is, it's a wordy question, and it looks pretty innocent on the start of it. And you can figure this out without algebra. You don't have to create an expression for this if you don't want to. But with it being 2 marks, the odds are that they're wanting you to show some working for it. So there's a couple of ways we could look at this. But the most straightforward way for me would be to create a bit of an expression. So what we're going to do is we're just going to take this step by step. So Matt thinks of a number. We don't know what that number is. So what we can do is we can use a letter like Y, say, to be the number that Matt is thinking of. Then what we need to think about is what he does next. So he multiplies Y by 4. So if we had Y and we multiplied it by 4, we'd actually end up with 4y. We've got 4 lots of y now. So it's 4 times whatever his number happens to be. The next thing he does is he takes away 5. So we've got 4y minus 5. And he ends up with 39. That is our expression that we can use, or our equation, should I say, to help us find out what this number is. So now what we can do is, similar to the solving video we did, we can just try and isolate y on its own. So at this point, what we can do is we can say, okay, I'm trying to get to y on its own here. So what have I done to get to y on its own? So the first thing we can get rid of is this minus 5 here. So if we add 5 onto this side of the equation, we can get rid of that altogether. But we'd also have to add on 5 to this side of the equation as well to balance it out. So we can just say 4y equals 39 plus 5, because we're getting rid of this 5. And that would give us 44. And then we can say, well, y is 4 times smaller. So we've divided by 4 here. So we'd have to do the same to this side. So 44 divided by 4 gives us 11. And that will give us our answer. That's one method of doing it, is using the expression. And just being able to tease that information out. The other way you can do it is almost in a reverse fashion. So you might remember on one of your other papers that you had the little number machines and you were having to kind of put your information into those number machines. So method 2 that you could look at is potentially read the question backwards and say, okay, so we ended up at 39. He took away 5, so we're going to add 5. We're going to do the opposite. And he multiplied by 4, so what we're going to do is we're going to do the opposite of that, and we're then going to divide by 4. This was step 1, so we're going to have to put that first. We're going to do that bit first. And then we would look at that as a sum on its own. So you could say 39 plus 5 gives us our 44. 44 divided by 4 equals 11. So there's 2 ways we can do that question. There's actually more than that, but the 2 main ones that I would consider, and it depends on how how your brain works, how you see the question, which way you find easier. Some people prefer the arithmetic and being able to do it backwards like this, and just being able to kind of invert all of these parts here, so turning your takeaway into a addition and turning the multiplication into a division, and being able to do it in that order. Personally, I actually, for those types of questions, I find the expression method easier. but it just depends on personal preference. So there's two ways to do that particular style of question, is my point. So feel free to use the one that works best for you. So moving on to our next one. Again, it's quite a wordy question again. So we'll have a little wander through this. I'll make this the last one for this video, and then hopefully we can fit a couple more in after. So what this question is saying is the letter S represents the area of this square. So everything inside of this square, because the area is the inside, remember, is represented by the letter S. And the letter T represents the area of the triangle. So T is everything inside the triangle. So the area of this shape, because it's the square with the triangle attached, is just S plus T. So S for the square, T for the triangle. So the first thing it asks for is an expression for the area of this shape below, and give your answer in its simplest form. So there's a couple of things we can look at here. So we've got S plus T plus T. So we've got two triangles that are the same size. So we could say S plus T plus T. So that's one thing we could do. So if I just hop down here, taking this down. So we're just going to do, if we said S plus T plus T, for example, we could write that. Just going to take that S away over there. And that would technically be right, but is it in its simplest form is the question, and probably not. So what we'd really be looking for ideally is a square plus two triangles. So what we could do is we could group those T's together. So we could say it's S plus 2T. Because we've got T plus T here. That's it. That's what we're looking for. Now, part B is an expression for the shaded area of this diagram. Now, what this is essentially doing is it's using this square and it's placing a triangle inside of it. So it's placing one of the triangles inside of it. So the first thing we've got to think about is we've got our square, and the S, the square, would give us if that whole thing was shaded in, if the whole square was shaded in. But we don't want that. We want the full square that was shaded in, but we've then taken away this triangle section of it. So our simple expression for that can be the square minus the triangle, or S minus T in this case. And that would be enough to get you this final mark here. So I'll just do this last one quickly. So expressions again. I double a number, then subtract 3. The result is 75. What's the number? So if we double in a number, that's going to be x, and we've doubled it, so we can count it as 2x. We then take away 3, and that equals 75. So then what we'd be looking for is we'd add 3 to either side, so we can have 2x equals 78, and then x equals 39. Or if you prefer the other method, you can have 75 plus 3, and then we can divide by 2. And that would give us, that would give us 78 divided by 2, which would get us to 39 again. So either way is worth your while, but both ways will leave you with 39. And the next questions are going to be solving some equations, so I'll do that in the next video for you. But if anyone has any questions about what we've covered in this particular video, just contact me via Teams or email, or feel free to mention it to one of your tutors, and we can have a little run through with you then. Speak to you soon. Bye now.